Last episode, we said the agent core must stay pure so it can cleanly talk to a model. But to engineer that conversation well, you have to know what's on the other end of the line. So, what actually happens to your sentence the moment it hits a language model? First, the model doesn't see words, it sees tokens. Your sentence gets chopped into chunks, often word pieces, not whole words. Tokenizing might become token plus izing. Each chunk gets an ID number. That's it. To the model, your prompt is now just a list of integers. But integers don't carry meaning, so each token ID is used to look up a row in a huge table, and that row is a long list of numbers, a vector, and embedding. This is the model's first real act of understanding, turning a meaningless ID into a rich point in space. And that space is the beautiful part. It's learned so that meaning becomes distance. Words used in similar ways end up as nearby points. The famous one, take king, subtract man, add woman. You land almost exactly on queen. The model never memorized that. The geometry of the space encodes it. Now the engine. Attention. Each token asks a question. Every other token offers an answer. And the token pulls in a blend weighted by how relevant each neighbor is. In the cat sat on the mat because it was tired. Attention is how it figures out. It means the cat, not the mat. Every token, looking at every token. Let's watch the whole pipeline run end to end on our one short sentence. Text in tokens, then the embedding map, then the attention grid lighting up. Stage 1, tokenization. The sentence splits into colored token chips. Notice the count. That count, the number of tokens, is the thing the harness will obsess over for the rest of this course. Stage 2. Each chip drops into the embedding space and becomes a point. Related words cluster, unrelated ones spread out. The model now holds meaning as position. Stage 3. Attention. We draw the grid, every token down the side, every token across the top. Each cell is how much does this row token care about that column token. Watch the cells light up. And here's the catch you must remember. The grid is n by n. 10 tokens, 100 cells, 1000 tokens, a million cells. Double the tokens and the grid quadruples. That's what order n squared means. Attention cost grows with the square of the prompt length. So every token you put in the window isn't just storage. It's a tax on every other token because each one now has to be compared against this new one. More context literally makes the model spread its attention thinner. That's not a bug, it's the geometry of the mechanism. This single fact, attention isn't squared, so more context is never free, is the seed of the entire next episode. We'll look at the context window as a finite attention budget, how prefill and decode actually run, and why quality starts to rot before you ever hit the limit.